This lesson is going to show you how to divide decimals with another decimal. And I want to start by showing you how the relationship between numbers stays the same. So we can start with 500 divided by 100. Well, I know that 500 divided by 100 equals 5. 100 can fit inside of it 5 times. Now let's see 50 divided by 10. I know it can't go into 5, but 10 can go into 50 5 times. So notice that my powers of 10 changed from 500 to 50, and 100 changed to 10, but the answer is still 5. So the number of groups that I can make has not changed. The next question is 5 divided by 1, and we know that also equals 5. So even though zeros have been going away on each problem, the distance between the two numbers is the same amount. So looking at our last example, I wanted to show you what we do in order to make dividing a decimal by a decimal number easier. So I'm going to start by writing 0 and 5/10 under the house, divided by 0 and 1/10. Now, I know that this outside number tells me how many groups I want to make. And I can't make 1/10 of a group. The second that I start dividing things up, I've already made a group. So groups can only be whole numbers. So I'm going to look at this outside number, 1/10, and I need to change it to a whole number. And I'm going to ask myself, how many times would this decimal need to move in order to change 1/10 to one whole? And I would only need the decimal to move behind the 1 once. And I know that I can change that number by multiplying by 10. So when I multiply 1/10 by 10, my new number is 1. And we know math is all about patterns, so if I do something on the outside, I'm also going to do it on the inside. So I'm going to also move this decimal over one time, which is the same as multiplying my inside number by 10. Now I'm really looking at the problem I just solved. 5 divided by 1. And we already know 1 can go into 5 times, and that will fit evenly. So my answer to 5/10 divided by 1/10 is 5. And the way that I dealt with that decimal is I asked myself how many times I could move the decimal for it to become a whole number outside. And if I moved it once on the outside, I moved it once on the inside. Let's try another example. So in this problem, I have 0 and 735 thousandths. And I want to divide it into groups of 0 and 35 hundredths. And as I said in the initial problem, I can't make 35 hundredths of a group. I can only make whole numbers groups. So I'm looking at my outside number, and it's not a whole number, and I need to know how many times would I need to move that decimal in order for 35 hundredths to become a whole number. So I could move it here, but that would be 3.5, and that's not a whole number. So I can move it twice. And I know this would happen if I were to multiply that number by 100. Well, if I move the decimal twice on the outside, I have to do the same on the inside so that the relationship between the numbers stays the same. So it's as if I took both of these numbers and multiplied them by 100. So the decimal moved twice outside, the decimal moved twice inside. So my new problem now looks like 35 is outside of the house, and underneath my house I have 073 decimal, and I know if there's a 0 at the front, I do not need to write it. So 73 and 5/10. Because the outside number is now a whole number, I can divide just like I did with dividing decimals by whole numbers. I'm going to start by raising my decimal to the roof. 35 cannot go into 7. 35 can go into 73, and I know it can go in 2 times. 2 times 35 is 70. When I subtract, 3 minus 0 is 3. I know 7 is going to put me a 0. After I subtract, I'm going to bring down my next number, which is 5. And just when I was dividing with whole numbers and decimals, because the 5 came from behind the decimal, my new answer is also going to go behind the decimal. 35 can go into 35 one time, and 1 times 35 is 35. I subtract and get 0, which means I can stop here. Now, when I'm dividing, I want to be very careful and I want to check my work, and I can check this problem with multiplication. So I'm going to use my 2 outside numbers and multiply them. So 35 times 2 and 1/10. So now I'm going to ignore my decimal. 5 times 1 is 5. 1 times 3 is 3. Down a row, add a 0. 2 times 5 is 10. 2 times 3 is 6, and 6 plus 1 is 7. When I add, I get 5, 3, 7, and I know there is 1 behind my decimal in the problem, so my decimal should go between the 3 and the 5. And if I look at this answer, 73 and 5/10 is what I started with. So my final answer for this problem is 2 and 1/10. My next example is 64 and 8/10 divided by 8/10. So my first number is going to go under the house and divided by 8/10. Once again, my outside number is not a whole number, so I'm going to ask myself, how many times do I need to move that number? I know that if I move the decimal behind it 1 time, this number outside will look like 8. And if I move it once on the outside, I'm going to move it once on the inside. And really what I did was use a power of 10. If I multiply 8/10 by 10, it becomes 8. If I multiply 64 and 8/10 by 10, it becomes 648. And just as I saw in the beginning problems, I noticed that just because I'm adding powers of 10 or taking away powers of 10, my distance between those two numbers remains the same. So now this new problem looks like 648, the decimal at the end, divided by 8. Now I can raise my decimal to the roof and start to divide like normal. 8 cannot go into 6, but 8 can go into 64, and it can go in 8 times. 8 times 8 is 64. When I subtract, I'm going to get 0. After subtract, I bring down the next number, 8. 8 can go into 8 one whole time. 1 times 8 is 8. When I subtract, I get 0. And if I needed to bring down another number, I know there are zeros behind the decimal, and 8 would go into it 0 times. So I could have stopped when I originally got my 0 left over. Now, to make sure I'm correct, I'm going to multiply the 2 outside numbers. And you want to do this on all of your work because then you'll know if you're going to get 100 or not. So 81 times 8. 8 times 1 is 8. 8 times 8 is 64. So I got 648, which is what I started with. Now, if you want to check it with your original problem, it should work out the same way. So in my original problem, I had 8/10. So let's try 81 times 8/10. 8 times 1 is 8. 8 times 8 is 64. And I know this next row would be all zeros. And I would ask myself how many numbers are behind the decimal. Well, there's one behind it in the problem, which means there's one behind it in the answer. So this still gives me 64 8/10, which is what I started with here. So using a power of 10 helps me move the decimal, and as long as I move the decimal the same number of times on the outside number as I do on the inside number, then my answer for the problem should be the same. So 64 8/10 divided by 8/10 is equal to 81. Let's try one more example together. Here I have 0 and 72 hundredths divided by 0 and 15 hundredths. So I can ask myself, how many times do I need to move this decimal for 15 hundredths to become a whole number? And I know that if I were to multiply this number by 100, it would move the decimal twice, so it would become 15. And if I move it twice on the outside, I've got to move it twice on the inside. So I've multiplied both numbers by 100, which means the relationship between these numbers is still the same. So I moved it twice on the inside, this new number 072 with a decimal at the end. You're not going to write the 0 in front of a whole number. I'm going to go ahead and add decimals and zeros and raise my decimal to the roof. So when I start this problem, what was 15 hundredths going into 72 hundredths has now turned into 15 going into 72. I know that 15 cannot fit inside of 7, but it can fit inside of 70. So I'm going to go to the side and try a few math facts. 3 times 5 is 15, 3 times 1 is 3, plus 1 is 4, so that's 45. I could probably get closer. 4 times 5 is 20, 4 times 1 is 4, plus 2 is 6, and if I were to go 15 more, I would go above 72. So the closest number I can get to right now is 4. 4 times 15 is 60. When I subtract, I get 2, 1. After I subtract, I bring down the next number. Now, this 0 came from behind the decimal, which means that my next answer should go behind the decimal. So I need to see how many times 15 can go into 120. So I'm going to jump up a couple numbers here. I'm going to try 15 times 7 and 15 times 8. 7 times 5 is 35. 7 times 1 is 7. 7 plus 3 is 105. There we go. And now let's try 8 times 15. See if we can get closer. 8 times 5 is 40. 8 times 1 is 8, and 8 plus 4 is 12. So dead on 120. So 15 can go into 120 8 times, and 8 times 15 is 120. When I subtract, I get 0, and I don't need to bring down any more numbers because I have no remainder, no numbers left over. So I'm going to erase my scratch work over here. And the last thing I need to do is check that my answer is the same and correct with multiplication. So, multiplying my outside numbers, 4 and 8/10 times 15. 5 times 8 is 40. 5 times 4 is 20, plus 4 is 24. Down a row, add a 0. 1 times 8 is 8. 1 times 4 is 4. When I add, I'm going to get 0. 4 plus 8 is 12. 1 plus 2 is 3. And 3 plus 4 is 7. And I know I had one number behind the decimal up here. So one number behind in my answer. So 72 is what I started with, even though it happened after I moved my decimal 2 places. And just like you saw at the beginning, all of the answers were 5. All of my answers should be 72 for this problem. And if you want to double check it to be sure, then I could go back using what the original problem gave me. The original problem used 1500ths, and if I were to multiply 4 8/10 times 1500ths, my numbers would work out the same. The only difference is when I get down to this bottom answer, this would mean 3 numbers are behind the decimal. And if I put 3 numbers behind the decimal, that gives me my original number of 7200ths. So with or without moving the decimal, I know that my answer is equal to 72. Try these 4 practice problems. Make sure that you know the first number is the number that goes under the house. The second number should be on the outside of your problem. And to make sure you're doing it correctly, read your problem when you're writing it down to see that it matches what you're saying. 12 8800ths divided by 4/10. Check all of your answers with multiplication to make sure that you're getting the number you initially started with.